this lecture, we are going to talk about one of the methods used to solve problems under quadratic equations. And the method we are going to discuss is called the factorization method. To illustrate what factorization method is, let us consider a basket containing fruit and stone, and the fruit in this case, let's say orange. Now, if our task is to isolate the orange from the stone, what we've just succeeded in doing is to factorize the items contained in the basket. So our major focus in factorization is to look for the possible way to isolate the items in a particular expression, or in this case, in a particular quadratic expression, and make sure that we connect them with arithmetic operations like addition, subtraction, multiplication, and in rare cases, division. So, to discuss what factorization is in proper, we have to consider the trinomial expansion ax squared plus bx plus c, and I'm sure you to adequately discuss what factorization is, we are going to consider trinomial expansion ax squared plus bx plus c, and I'm sure you are familiar with that this expression is the general form of a quadratic expression. So we are considering factorization method. We have other methods we can use to solve quadratic equations, and we are going to discuss those methods in details in subsequent lessons. We have methods like the completing the square method, we have the algebraic method, in some cases, some texts call it the formula method, while the generic name for it is the almighty formula, and I'm going to show you why they call it almighty formula. Then the last method we can use to solve quadratic equation is the graphical method, but for this course we are not going to talk about the graphical method. So, method of factorization. Consider the trinomial expression ax squared plus bx plus c. We all know why it is called a trinomial. It is called a trinomial because it contains three monomials. This is the first monomial, while this is the second monomial, and c is the third monomial. So this polynomial can be split into two based on the factors that can be obtained from it. And let's say the factors are alpha and beta. So we can get the roots of this trinomial expression to be x minus alpha and x minus beta. So if these are the roots of the quadratic equation, and what are roots of the quadratic equation? Roots of the quadratic equation is basically the values obtained when the quadratic equation is solved or equated to 0. So if we equate this trinomial expansion to 0, we have ax squared plus bx plus c equals 0. So we can have x, like I said, x minus alpha and x minus beta as the roots of the solution to the quadratic equation, as they are the values of the independent variables that would make the expression to be equal to 0. Having said that, we can obtain the value, we can equate these solutions or the roots to 0. So we can have x minus alpha equal to 0 or x minus beta equal to 0. So we can solve, there are two possible ways of obtaining the solutions to the roots of the quadratic equation. And the first possible way is when we have the coefficient of the unknown is equal to 1, and the other way is when the coefficient of the unknown is not equal to 1. I'm going to show you how this is done. So we can factorize quadratic equations based on these two methods or these two approaches, as the case may be. So let us consider a quadratic equation of the form. Let us consider this quadratic equation. Say x squared minus 6x plus 8 equal to 0. In this case, we use this to explain the first approach when the coefficient of the unknown is equal to 1. You will realize that the coefficient of the highest power of x here, of the first term, is equal to 1, because, like I said in our previous lessons, that there is an invincible one over here. So to make it easier, to make it simpler, we have to remove the 1 and call it x squared, because it's easier to call it x squared than calling it 1x squared. Is that okay? So factorizing this equation is very easy. First thing is to multiply the coefficient of this invincible one of this x squared, is to multiply the coefficient of x squared by the constant term. And since 1 is the coefficient of x squared, we have 1 times 8, which is equal to 8. Now, since we have 8 as the value here, the next step is to look for the factors of 8. And I'm sure you know what factors are. Factors are numbers that can divide another number without any remainder. I'll take that again. Factors are numbers that can divide a particular number without any remainder. So for 8, we can say the factors of 8 are, we have 1 as the factor, we have 2, we can have 4, and 8 itself. So these are the factors of 8. Having got the factors of 8, the next step is to look for a way to assign signs to the factors such that we would have minus 6. So the next step is to assign signs to any two factors of 8 to make sure we have minus 6. And if we pair these factors, we have 1 and 2, we can have 1 and 8, we can have 2 and 4, we can have 4 and 8. And we can also have more than that. Which two factors from here will give us minus 6? Of course, if I have minus 2 and minus 4, this is going to give me 6. So therefore, the two factors I'm going to consider for this particular problem are minus 2 and minus 4. So since we have that already, we can say we will now put the factors inside the original quadratic equation. And this is how it is done. We can have x squared minus 2x minus 4x plus 8 equal to 0. You realize that I've not altered anything in our initial equation, because x squared is here, we have x squared and we have x squared. Minus 2x minus 4x is the same thing as minus 6x, and we have 8 here and 8 here. So I've not done anything. What I just succeeded in doing is to impute the factors of 8 inside the original equation. So after doing this, the next thing is to pair them like this, such that we will now look for the common elements in each of the pair. So looking at x squared and minus 2, what is common to these two terms? You realize that the common factor here is x, then this will be in the bracket. We are left with x minus 2. So again, I've not done anything to this first pair over here. I've not done anything to this first pair, because if I decide to open a bracket, I still have x squared x times x will give me x squared, then minus x times 2 will still give me minus 2x. X times minus 2 will still give me minus 2x. I'll do the same to the second pair. I have minus, what is common to 4x and 8? I have 4, then I'm left with x minus 2, which is equal to 0. I'll give you a very quick hint to confirm if you are correct. The value in what you have in the first bracket here must be the same thing with what you have in this second bracket. If they are not the same thing, then there's something wrong with your calculation. Is that understood? So, having said that, we have to pick one of them. So, x minus 2 is over here. Since they have the same value, we have to pick one of them and pick these two. So this is x minus 4 equal to 0. So because x minus 2 times x minus 4 equal to 0, we can split it to be equal to x minus 2 equal to 0 and x minus 4 equal to 0, which is still the same thing like what I said in the introductory part of this lesson. I said, remember we had something like x minus alpha equal to 0 and x minus beta equal to 0, where I said alpha and beta are the solutions or the roots of the quadratic equation. So if I decide to solve this further, I have x equal to 0 plus 2 or x equal to 0 plus 4. So this gives me x equal to 2 or x equal to 4. This is the complete factorization of the particular equation we were given. Now, I said that roots or solutions to a particular quadratic equation are the values that would make that particular quadratic equation to be equal to 0. So let us confirm if these two values over here are actually the roots or the solution to the quadratic equation. So let us write the initial equation back. The initial equation was x squared minus 6x plus 8. It must be equal to 0. So what values of x will make this particular equation to be equal to 0? That is our aim. And since we have the values to be 2 and 4, let us independently put the values of 2 and 4 in this particular equation to check if the value, if we have 0 as our final answer. So when x equals 2, so we have 2 squared minus 6 times 2 plus 8 equal to 0. 2 squared is 4 minus 12 plus 8 equal to 0. And this gives us minus 8 plus 8 is equal to 0. Therefore, these will cancel out and we are left with 0 equal to 0. Since the left hand side is equal to the right hand side, which is equal to 0, then 2 is a root of the quadratic equation. And some persons can call it 2 is the solution to the quadratic equation. Let us consider for 4 as well. So when x equal to 4, so we have 4 squared minus 6 times 4 plus 8 is equal to 0. Alright, 4 squared is 16 minus 6 times 4 is 24 plus 8 equal to 0. This will give us minus 8 plus 8 is equal to 0. Therefore, 0 is also equal to 0. And these two values are the only solutions we have to the quadratic equation. So in summary, factorization method helps us to deduce the solution to the particular equation that we are given. Now, let us consider another example before I wrap it up on this segment. Let us consider another example to explain adequately the concept of factorization. Now, what if we are given the quadratic equation 3x squared plus 5x minus 2 equal to 0. This is our quadratic equation. We'll use this to explain the second approach where the coefficient of x squared is not equal to 1. So if the coefficient of x squared is not equal to 1 in this case, which is 3, so we have to multiply the coefficient of x squared by the constant term again. So we have 3 times 2 equal to 6. Now, having said that, the next thing is to find the factors of 6. And the factors of 6 are 1, 2, 3, and 6 itself. Now, which of these two factors can we combine together to give us plus 5? Which of these two factors can we combine together to give us plus 5? So we can consider using 1. Okay, we have factors 1 and 2. We have factors 3 and 6. You can also have factor 1 and 6, and so on and so forth. But the factor that best explains what happens in this case is 1 and 6. Because the combined sign, you can get the value for the coefficient of our middle term here, which is plus 5. So minus 1 plus 6 will give us what? Plus 5. Therefore, we can go with minus 1 and 6. So our next focus is to replace the factors with the coefficient of the middle term. And by that, I mean 3x squared plus 6x minus 1x minus 2 equal to 0. And you still realize that we have not done anything to the initial problem, because what we just did was to put the factors of 6 inside the equation. We have 3x squared here. We have 3x squared plus 6x minus 1x will give us plus 5x, then minus 2. So the equation still remains intact. Now, we have to group them in twos so that we can find the common factors between them. So what is the common factor between plus 3x squared and plus 6x? Of course, the common factor is 3x into x plus 2, because 3x times f will give us 3x squared, then plus 3x times 2 will give us 6x. So we have minus, what is common to both? 1 into x plus 2. Remember, I said that a good hint is to check if what is here in the first bracket is the same thing with what is in the second bracket. And if they are the same, yes, you're on the right track. If they are not, then you have to check the previous steps to know where the fault came from. So we can continue by saying x plus 2 in one bracket, then 3x minus 1 in another bracket equal to 0. And this gives x plus 2 equals 0, or 3x minus 1 equals 0. So therefore, we have x, if we subtract 2 from both sides to make x stand alone, so we have x plus 2 minus 2 equals 0 minus 2, or 3x equals 0 plus 1. Therefore, this will cancel out and we are left with x equals minus 2, or 3x equals 1. Since we are looking for the value of x on both sides, so we can say here x is already equal to minus 2. Then if we divide through by 3, just to make x stand alone, we have x equals 1 over 3. Therefore, the roots of this equation are x equals minus 2 and x equals 1 over 3. This simply implies that if I put the value of x as minus 2 and 1 over 3 in the original equation, I'm going to get the value of 0. So let us check if these are actually the roots of the quadratic equations. So from the initial equation, we have 3x squared plus 5x minus 2 equal to 0. So when x equals minus 2, then we have 3 into minus 2 squared plus 5 into minus 2 equal to 0. This gives us 3 times 4 minus 10 minus 2 equals 0. And we have 12 minus 12 equal to 0. Therefore, 0 equal to 0. Since this root, then minus 2 is one of the roots of the quadratic equation. As well, we can test for 1 over 3. So let's check. When x equals 1 over 3, then we have 3 into 1 over 3 all squared plus 5 into 1 over 3 minus 2 equal to 0. And this gives 3 into 1 over 9 plus 5 over 3 minus 2 equal to 0. This will give us 3 goes here, 3. So we have 1 over 3 plus 5 over 3 minus 2 equal to 0. If you find the LCM of the 3 terms, we have 3. This gives us 1 plus 5 minus 6 equals 0. So this simplifies to 0 over 3 equals 0. And you know that 0 divided by 3 will give us 0, which is equal to 0. Of course, this also gives us 0. Now, we've been able to discuss what factorization is and how we can use factorization method to bring out the roots of a particular equation. We have also talked about the 2 approaches we can use to solving factorization problems. With this knowledge, you can go further to trying any problem under factorization, and I'm sure you should be able to solve them. And in case you still have some reservations, some issues, please kindly drop them on our platform, as I'm going to attend to those questions in due time. In our next lecture, we are going to consider other methods used to solve quadratic problems. And the method we are going to consider is the algebraic formula method. See you in our next class.